Greetings, I'm Reverend John O'Toole. Today we're going to do something different. Today we're going to have some fun. Now, I'm in the Northeast. I'm in the Berkshires, the hill towns. Should I make myself any more clearer that we are remote? And we have a tendency of losing power every once in a while. It's surprising, but we do. There are people around the country that seem like they never lose power. I don't know where they live. Maybe it's a magical land. But anywho, those of us that live in the Berkshires, most of us have generators, and we have other means of survival. Well, today, we're going to show you how to build a backup system for something in your house. Now, you can go online and see all kinds of charts about how much energy you need. Like, for example, typically people will buy like a 3,500 watt generator, and they can run a lot of different things in their house while on the generator. Of course, the closer you get to that 3,500, the more at max that generator is going to run. Well, generators aren't so bad. They're kind of a good thing. A lot of the really cheap ones don't have a very clean power output. So if you're running electronics, some electronics are going to be protected and some things aren't. And the electrical noise from the generator could in fact damage your equipment. Now, of course, if you lose a whole freezer full of food, you're going to think that a generator would be a really good idea. Now, an other alternative is to do a battery backup. Now, essentially, battery backups are all the same in theory, but in practicality, they're all different. The two main components to a battery backup is an inverter, which converts DC power or battery power to AC that your appliances in your home or in your camper or on your bike, if so inclined, or in your car. Say if you want to run your laptop in the car, you need a small inverter to plug into your cigarette lighter and to run your laptop. Now, depending on how much you need your laptop, you might have to have your car running while you're using your laptop. I used to have that problem. In order for me to connect to the Wi-Fi signal in Albany, New York, I had to actually have my laptop running to generate enough power to connect to that Wi-Fi signal that was free. And even to keep my laptop running, it was better to run it with the car running than to kill the battery. Now, batteries, say a 12-volt battery, you don't have 12 volts of power. You only have 12 volts of power until it gets down to maybe 10 volts. And then at 10 volts, your inverter is going to stop because it knows it can't draw that 100% of power out of your batteries. So anytime you see a rating for a battery system, whether it's for one of those jump packs, or a backup generator, you see them a lot now. They're in boxes and they charge, some amount of money, and they supposedly have a charger built in, and you can hook it up to solar panels, sort of, and you can charge it with your solar panels, sort of, and you can run some appliances. Now, if it says that it's a 1,000 watt hour backup generator, you don't have all that power. But in essence, there's a formula. Yes, we're going to talk a little bit about math. There's a formula. I should actually put my glasses on. What do you think? I do look better with my glasses on. And then I can see the screen. Oh, it's such a difference. So There's a formula. It's been around for ages. Anybody that's been at anything with electronics or electrical knows this, and it's called Ohm's law. And it has a bunch of variations. The one that we're particularly interested in is power, which is P, equals amperage, which is current, or the ability for power to flow through the wire, just like flowing through a garden hose. The amount of water going through a garden hose, like gallons per minute, that is kind of what amperage is, or current. And then there's voltage. So P is equal to amperage times voltage. If you have a 12-volt system and you're drawing 10 amps out of the battery, like if you just want a vacuum, most vacuums are about 10 amps. So 10 times 12 is 120. So you need a minimum of 120 watts coming out of your inverter and also your battery bank. Now 120 watts coming out of your battery bank is a lot of power for a small system, for one of those jump packs. It's a lot of power. And you might want to think in your head, when you see, you know, 1,000-watt backup battery backup generator that you see like in boxes, you want to divide that number in half, because it's not going to give you a true reading. Once your voltage and your power and your amperage of that battery drops down to 50%, that is where you want to stop pulling power out. If you keep going below 50% of charge of that battery, you can kill those batteries. And what did I say in the beginning? Your two most important components are the batteries and the inverter. Everything else that's involved with those two components are for making everything connect together and safety. Now the third component is if you're going to have some solar panels on your system to charge your battery bank when the sun is up. Seems like mostly these days, for quite some time, is the power usually goes off at night, and there's no solar at night. Maybe on the moon. Maybe. I don't know, because I don't live on the moon. Maybe somebody out there can enlighten me about what it's like to live on the moon. Now, some parts of the world, they get a lot more sun than we do up here in New England. We typically get about 6 hours, maybe longer in the summertime, and definitely less than 6 or 5 hours in the wintertime. But it doesn't hurt to set up some solar panels and having them help charge your battery during the day if for some reason the power company can't get your system back up and running, or you're camping. So with the solar panels, you need something called a charge controller. The charge controller will do is it'll monitor your battery bank voltage, and when you reach your optimum peak, which is about 12 volts for a 12-volt system, 24 for 24-volt system, and 48 for a 48-volt system, depending on which system you've set up for. Now, the most efficient system you can set up is a 48-volt system, and that would be meaning taking 4 12-volt batteries and put them in series. Now, I might be getting outside of the realm of this particular class. However, it's all little things that you're going to hear over and over again when you're out there watching videos about how to set up your own system. Now, for example, my recommendation, if you really wanted to set up some kind of a solar backup system for your home and you didn't want to use a generator, I would suggest taking like your your cave or your garage or your workshop and set that up on a solar battery system that you can run independent of the grid. And once you're successful with that, if you were to have a power failure, you could run an extension cord over to your house and run your refrigerator and your heat and your TV. And what this particular system is for my internet router, so that I can still watch my TV while I'm huddled under a blanket. And now I already have an existing battery backup system in my house, and it's essentially a larger version of what you're going to see me build today. And it does run part of the house so that I can get by through the night until power is restored. The longest I've been out on that particular system until I exhausted my batteries was about almost 30 hours. And then I had to get a generator going to get some charge into the batteries. In fact, it was kind of sooner. But you know, when it's sometimes getting to that generator is not as easy as it sounds. So if there's something that you want to play around with, do the research and ask questions, ask tons of questions, and look for people that are doing it successfully. I have a particular favorite inverter out there, and it's called an MVP. MVP inverter. If you go on eBay and do a search for it, you'll see them come up. They're out of Taiwan. There are some copycats out of there, so you want to try to stay away from the copycats, and they'll change the name and the logo. But it's MVP. They often refer to as a PIP. And that's a really nice inverter, and I thought about putting it for this build, but I haven't done it yet, and I'm going to just stick with a smaller inverter that I already have. But the advantage of that inverter, like for example, well, the advantage and disadvantage. One advantage to it is that it's designed for European power. So it has a 230 output. So you'll have to run it through some type of transformer that you can convert it over to our split phase system. And if you understand what I'm talking about, great. If you don't, you're going to have to do more research. But it has a battery charger in it, and it has an inverter in it, depending on which size you get. Now there is a 120 12 volt, but that's only 1,000 watts. It's not going to power very much. Your refrigerator, your freezer, I don't know about the heat. If you have a furnace like I do that runs on kerosene, it uses a lot of power. And I don't know how much it uses, and I really should know, but I do know my electric bill jumps up a lot in the wintertime running the furnace. But you can alternate. You don't have to have it constantly running your refrigerator or freezer. You have to get them up to temperature again or down to temperature, and then you can turn them off and don't open the doors for a while if you have an energy efficient. Now, this video is going to go a lot longer than I am. Maybe I'll be splitting these up. I don't know. But that's a kind of overview of creating an off-grid system. Now today we're not going to be using a charge controller for solar. This is going to be strictly battery backup with an inverter. And just a really simple system. Now down the road, if I wanted to add a solar panel out in the yard, I could run the system in and put it on a charge controller. I mean, when buying a charge controller, just like the inverter, just like the battery, you want to read all the reviews and get something reliable, something you can afford and something reliable. My suggestion is to go to places like eSolar or Yeah, well, eSolar is a really good site to go to, and you can look around. You can get deals on Amazon and eBay, but you know, if you buy something by a price and not by quality, it's exactly what you're going to do. Now, with the charge controller, what it will do, particularly don't buy Harbor Freight charge controller. Now, what a charge controller will do is it will allow the solar panels to charge in a most efficient way until the batteries reach their capacity, and then the charge controller will turn off using solid state stuff and not a real switch. So if your solar panels are still putting out 100 watts into your batteries and your charge controller stops it, that charge controller has to handle the energy of turning off those panels. And often if you buy a cheap one, they will tend to overheat and fail. And it's not a good thing to have a failed charge controller in your system. So what we're going to do today is that we're going to build a system for keeping my internet going. Now, in the past, what I have done is I had a UPS, a cheap $40, $50 UPS that I bought at a box store, and I have been using it for a long time. Now, one of the good things about that is that it will shut down your computer at a power failure, and then go on from there. It's not a very clean energy device, so it doesn't produce a really good clean power, but it's kind of adequate. And what you could do with one of those is you could take out the battery that it's in it and put it onto a bigger battery that has a higher capacity. So what I wish to do is basically eliminate it, or I might just leave it on my computer. And when the internet comes down, it will still cycle down my computer if I'm not home to do it, and leave the internet running, so that I have internet access throughout the whole power failure. Because if you're trying to get a hold of the outside world and you can't make connection on your cell phone because you live in the hill towns, then you still have access to the internet, and you can still watch your very favorite shows on Netflix and Amazon if you have your internet running. Yeah, get a book. Yeah, I know. So, we have an open slate, as you can see on my other camera, and in fact, you go to eSolar, they have setups for designing your own system, and they'll help walk you right through it right on their website. And it's really easy to figure out how many solar panels you need, how much power you need, what your inverter is going to be, and they have all the parts. Now, the only thing is, if you're shipping things like batteries, that can get kind of pricey to ship. So you're going to want to either find an alternative to that or drive to Westboro. If you're in the hill towns, Westboro is only a mere 2.5 hours away, or a little longer, particularly if you stop at Cracker Barrel in both directions. And you could pick up all your batteries, all your solar panels. You can pick up everything. As a matter of fact, you rent a U-Haul trailer, and then you just go and pick everything up, and you bring it all back. So that's just possibilities. You can order from someplace from California, or you can just order from eBay, from eSolar, and they'll give you everything that you need, along with the technical assistance. So we have some products here. We have this here is an inverter. This is the very first large inverter that I've ever bought. I had a small inverter that I keep in my car to run my laptop. So this is the first one that I ever bought. It has power plugs on one side with a switch, And on the other side, it has a place to hook up to the battery. Matter of fact, it still has this cord on here to plug into a cigarette lighter. I think I was using it with my jump pack to power something. And then on the side, it has a ground lug. Now, it's very important to ground your system. If it's a permanent system, like say in your garage or your power room, you're going to want to drive a grounding rod into the ground as far as you can, preferably at least 6 feet. And everything needs to be grounded. The negative side of the battery needs to be grounded. All the solar panel cases needs to be grounded. Frames, poles, anything metal needs to be grounded. And on this device and on my charger, battery charger, there's a place for a ground lug, and don't ignore it because it's safety. You also want to use fuses, like in this box here. We're going to be using fuses, and some people use breakers. You're going to do solar panels, you can use breakers as long as they're rated for DC, direct current. You can't use any kind of breaker, it has to be a special breaker. Now, these are our fuses that we're going to put in. The one's going to be going on the inverter, and the other one's going to be going on the battery charger. Now, the system that I'm setting up is similar to an RV or a camper, where you pull into an RV park and you're going to plug in your RV into shore power, and you're going to run on shore power until you disconnect from shore power or the grid goes down, and then you're running on your inverter from the batteries. It's a little simple system, but it works. And it also guarantees that I have clean power all the time for the system because it's running off the inverter. Now, if you're running it from a generator that has horrible power, running it through this device right here, which is this here is an IOTA battery charger. And this replaces using solar panels or a battery charger that's built into your inverter. Because you can also get inverters that have battery chargers, just like I told you, with the PIP inverter. Has a built-in battery charger, so that when the batteries are low, it'll automatically charge up the batteries, and so will this one. So the other thing we have in our component list is our battery cable. So here is battery cable. This is 8-gauge battery cable. And it's very important to size this cable to the size of your inverter. Now, it is very important because two things can happen if you don't size your cable properly. The first thing is going to be that they won't actually perform the way you want it to do. You may not get enough power to your inverter to actually do what the inverter can do. The other thing that can happen is that they can overheat and they can melt. And that's something you really don't want to have happen. Poor performance and melting are a bad thing. And also when you're having it as a melting device, it's using a lot of power to do that. Now, this is just more math. So if you have, say, for example, I have a 750 watt inverter. So you want to take the 750 and divide it by your battery voltage. If it's 12 volts, you use 12. If it's 24, you use 24. If it's 48, then use 48. Now the nice thing about it is the higher the voltage, the smaller the cable. So if you're running an inverter, say for example, that's using like 3,000 watts, you're going to be using something like a number 2 knot wire, which is pretty big. It's a pretty big wire. But if you go to a 24 volt or a 48 volt, that wire size gets smaller. So it's less money to have to pay for your wiring. It's easier to work with, and your inverter runs more efficiently. Now you've got 48 volts that has to go up to 110 voltage, or you have 12 volts. It's down here. Let's put it at the bottom of the screen. And at the top of the screen, you have to raise that voltage up to 120 volts. Now you can see that you have to do a lot to do that. Now the advantage here is that I only need at the most about 200 watts to run this area. It actually, I have a power meter on the circuit, and I'm at 150 watts right now, and the only thing really on is the my computer with 2 monitors and you know, a couple of hard drives, the router, DSL router, that was either a very big truck or we're getting thunder. And the printer's in standby. Printer fax machines in standby. So that is what we have here. So what we're going to do is we're going to start mounting things on the board. And then as we go, we will see where we at. Now, right now I have 2 batteries that go on here. They're